Alright, we're going to start off this second video by answering or solving this equation for x. Hopefully you've taken a few minutes to try to solve this yourself. What we need to look at here is the fact that this problem, unlike the other ones we've looked at, has two x's. There's an x with the a, there's an x with the b. Now, most of you all would say these are not like terms, which you are correct in the sense that one has an ax, one has a bx, and so technically we cannot combine those two. However, they do have something in common. They both have an x. But the problem is I cannot solve for x if there's more than one of them. I've got to figure out how can I rewrite this equation so that I only have one x present. Alright, so I want you to go over here, my little thought cloud over here, and let's think about something that you're very familiar with, and that is distributive property. If I were to give you a problem, 4 parenthesis x plus y, and I wanted you to simplify that expression. Well, hopefully you can recognize in the parenthesis x and y cannot be combined. Don't write xy. xy means multiplication. X plus y is addition. Two very different things. So there's nothing I can do here. But on the outside of the parenthesis, attached by multiplication, because remember there's not a sign here, so it's understood multiplication, is a 4. So I can use the distributive property. I can take this 4 and distribute that to the x, and 4 times x just simply gives me 4x. And then I can take the 4, because I have to with distributive property, and distribute that to the y. And 4 times a positive y gives me a positive 4y. Now I still can't combine those because they're not like terms. This one has an x and this one has a y, but they do have something in common. They both have a 4. So what if I'd given you this first, 4x plus 4y? What if this was the first thing I gave you, and I wanted you to simplify it or go in reverse, think backwards? Well, you've got to figure out, where'd the 4 come from? How did x get a 4 and y get a 4? So if they both have a 4 in common, what I need to do is pull that 4 out. And if I go in reverse, this is the result that I would get. If I distribute backwards, if I take the 4 out instead of putting it in, this is where I would wind up. So these you can go forwards and backwards here with distributive property. So let's take this knowledge here and apply it to something that doesn't have any actual numerical values. So what does ax and the negative bx have in common? Well, they both have an x. So they must have not had an x to begin with, and then both of them, the x was distributed to it. So let's go backwards. Let's pull the x out. Now keep in mind, there's not more than one x out here. Okay? There's only one, just like there's only one 4. When you distribute it, that's when you start getting multiples of that value. So if I take the x out, it's going to be out here. The only thing left inside is what we had before distributing. So before distributing this x in there, we had an a minus a b. And that equals c still. I haven't done anything with that side of the equation just yet. So there you go. We did the distributive property backwards. We took the x out instead of putting the x in. Now you could think backwards or think the normal way with distributive property. X times a is ax, and x times negative b is negative bx. So we are correct in our reverse of the distributive property. Now what we have to do is we have to figure out how to get the x by itself. So I'm going to highlight the x because this is, I don't want this to move, just like we've done in the other problems. I don't want that to move. So that means everything in the parenthesis has to go. Well, I can't add b because it's stuck inside the parenthesis. These are grouping symbols, okay? And I can't just start removing things from inside the grouping symbol. So what I'm going to have to do is I'm going to have to move this entire thing all at once. Well, how is this entire thing attached to the x? Well, it's attached by multiplication. I could put a dot there. So the inverse of multiplication is division. Now I'm not dividing by A, I'm not dividing by B, I'm dividing by this entire expression in the parenthesis. So what I'm going to do, and it's actually very simple, is I'm just going to divide this entire side by A minus B. Now what I do to this side of the equation, I have to move to the other side of the equal sign and do the same thing over here. So I'm going to have to take that C and divide it by A minus B as well. So anything, no matter what it is, if it's divided by itself, even if it's an entire expression, A minus B divided by A minus B, anything divided by itself is 1. I no longer have A minus B on that side of the equation. The only thing I have left is X. And then to clean up the other side of my equation, I do have C divided by A minus B. And that's my answer. Once you get past the distributive property, if you can understand that and wrap your head around that, then actually solving this equation is very simple. It's really just one step of dividing by that expression in the parenthesis. So keep in mind, you can divide or you can distribute backwards to remove having two variables down to only having one of them. Alright, so let's take what we've learned so far about literal equations and let's apply that to formulas. Now, a formula is an equation that states a relationship among quantities. You all have dealt with several formulas already. The area of a rectangle, the area of a triangle, things like that, those are formulas. There's multiple variables in there, and you are looking at a relationship between what the length and width does to the area of a rectangle, that sort of thing. So if you will turn in your textbook to page 110, pause the video and take a few minutes to reference the common formulas that you find on that page. Now you are going to be expected to use some of these formulas now in this section and then throughout the year during different word problems. Plus some of these formulas are going to be very important to you when you get to geometry. So please take a minute to either write those formulas in your notes, at least reference those formulas and read through them. That way you are familiar with them for this section. Now, with those formulas, we're going to look at this equation or this word problem. What is the length of a rectangle with area 98 inches squared and base 14 inches? Alright, so let's highlight our information here. In yellow, I'm going to highlight the question. What is the length of a rectangle? That's our question. Length of a rectangle. That's what we've got to find. What we know, I'm going to highlight in blue. We know the area is 98 inches squared, and we know the base is 14 inches. So this is really good practice. This is something that you need to get in the habit of, especially when you get to geometry. Draw yourself a picture. Alright, let's bring up the rectangle. Let's draw ourselves a rectangle. And let's actually fill in this information in our rectangle. Alright, what is the length? Well, I have no idea what the length of the rectangle is, so therefore I'm going to make it a little cursive L. I do the cursive L. You'll see that in your book most of the time. That way it doesn't look like a 1. So there's our length. Area is 98 inches squared, so that means all this space inside this rectangle, the area is 98 inches squared. Now, just as a side note, this is how this is written correctly with your units. This is not an exponent. We're not squaring 98. Inches squared, this is a superscript number. This is your unit of measure for area. You have squared units in area. So please don't accidentally square your 98. It is part of your units. Alright, and then the third thing that we know is that the base is 14 inches. So the base of my rectangle here is 14 inches. Now, there's another word for base, and you need to make sure you know that. That is the width. So typically when you're dealing with rectangles. You're dealing with length and width. Okay? So this is 14 inches. Sorry about that. So we have area, we have length and width. So what formula are we talking about? Well, we are talking about the area of a rectangle, which is length times width. Area of a rectangle is length times width. Now, traditionally, you could just plug in the numbers you know. You know what area is, you know what your width is, you've got to find your length. And that you will still be able to get the right answer. However, in some short response questions, constructed response type questions, they're going to ask you to solve the equation for the variable you don't know first before you ever start plugging in values. So that's what we're going to do here. The variable that we do not know, which is the question up there in yellow, is length. So we've got to get the L by itself. There's only one thing attached to your L, W. So how is W attached to L? Well, they're side by side. There's not an operation between them, so that's understood to be multiplication. Well, what's the inverse of multiplying by W? It's dividing by W. So I'm going to divide this side by W. Now, again, if I divide one side by W, I have to go to the other side of my equal sign, which is just an A, and divide it by W. Keep your equation balanced. So, what I did to one side of the equation, I must do to the other. I'm dividing by W. I cannot literally divide A by W, so I'm just going to rewrite this equation. A divided by W equals anything divided by itself is going to give you 1. We've talked about that before. So that's where I'm left with my L. So there's my equation, solve for L. Now what I can do is take that equation and plug in the values that I know. So in place of A, I know my area is 98. And I'm not going to put my units whenever I'm trying to solve an equation. I'm not going to use my units in the actual equation. And I know my width is 14. And of course, what I'm trying to solve for is L. Well, 98 divided by 14 is 7. Now, in Algebra 1, we're finished. But what you've got to get in the habit of, and something you need to start doing now, is when you write your answer, especially when you're dealing with units, you've got to make sure you include your units. So our final answer is actually 7 inches. That's the width of our rectangle. Alright, actually I'm sorry, that's the length of our rectangle. Our width is 14. What you could do from here is multiply 7 times 14. That's your problem, length times width. Multiply 7 times 14 and see if you get 98. And if you do, that's the way you check your answer, then you know you have the correct length. Alright, what I would like for you to do is I would like for you to try this problem. There's going to be one third and final video for literal equations, and that video is simply just answering this question and then your summary questions you need to answer. So go ahead and write down the information from this problem, work this problem out in your notes, and then begin the third and final video for literal equations.